and explain everything so I could annotate on it and make sure that you have this technique available to you when you go back to do it yourself. First thing I'm going to do when I look at this kind of article is look at the journal that it's from and see if I believe that that journal is a reputable source. The journal is located at the top of the page. The International Journal of Antimicrobial Agents. Yay or nay? Just evaluating what it sounds like. Do they sound like a resource that may know something about disease, illness, and disease-causing agents? I would think so. It's not like it's, I don't know, Science Daily. It's not even National Geographic. Like, I would trust this more than I would trust either of those. It's not the New York Times. It's not, I'm trying to think of other websites. It's not CNN. It's not Fox. It's not Wikipedia. Okay, I'll give them some credit. The next thing we do is take a look at our title, which is located shortly thereafter on the page. Antimicrobial efficacy of silver ions in combination with tea tree oil against Pseudomonas, Staphylococcus, and Candida. Now, when you see things that are in italics, they're two words. The first one is capitalized, and the second one is not. What is that?
I know.
It's a genus and species, right? So we're looking at 3 different organisms done by genus and species. This one, protist. This one, bacteria. This one, yeast. What can you tell me about protists, bacteria, and yeast based on their classification? Not only are they 3 different organisms, they come from 3 different what? Kingdoms. So we're looking at 3 different kingdoms. Do you think that that makes this more or less credible? Or more or less interesting as an experiment? Because we're trying to test the efficacy. What's this word mean? Efficacy. How effective it is. So we're testing how effective these 2 treatments are in killing 3 different microbes from 3 different kingdoms. Better experiment? More interesting experiment? It's a different variable. It's worth looking at. Next thing we do, after we evaluate the title, we take a look at our authors. And authors' names are not likely going to mean a lot to you guys, and I don't expect them to, but I will point out none of the authors here have a first name listed. None of the authors here have a second name listed. The only thing you see is their legal name, their last name. Why would they do that? Why would this publication? It is the choice of the journal, by the way, to do that. So it is the International Journal of Antimicrobial Agents who chose to not publish any first names. What does the first name tell you about somebody?
Usually tells their gender.
Tells their gender. We intentionally leave that out. Some publications will leave that out. Why? Because there is still a bias in some places against certain researchers. There are some people who will discredit this article looking at it if it is either all males, all females, or a combination thereof. So a lot of publications that you'll see will choose to leave that out to remove that bias. It's an interesting thing to note. After their names, though, they have superscripts, A, B, C, D, and A, and B. Those correspond to where where they do their research. You don't have to know every research institution, but you do have to kind of have a good sense of whether or not it's someplace you're going to trust. If it's a university, that's when we start to rank in our heads the quality of research institution. So if I were to say, trying to pick a university without insulting anyone. Hold on. Case Western Reserve University, or Michigan State? Who has a better reputation as researchers? Case Western Case Western Reserve University, or Michigan State? Case, hands down. You don't have to think about it. You take the data from Case. I purposely chose Michigan State. Sorry. Every time you have that ranking in your head, you know what schools are known for what, and if you don't, it's something you can look up. Mr. DF and I were talking about we're going to South Dakota this summer. Don't ask how. It was a brilliant DF idea. When DF says you want to go to South Dakota, it's usually wise to just say yes. So we're going to South Dakota this summer. Can't think of any place I'd rather go. And he wanted to do a college visit while we were there. And we looked up the college and saw the composite ACT score of that college, and it is an 18. How many of you are like, yes, I trust that college's, that university, I trust their research? You're like, yeah. Composite ACT score from University of Michigan is typically around 29 to 30. Composite ACT score for the average student entering Michigan State, I want to say is 24 or 25. That gives you an idea of where we put these things and how we rank universities. Problem is this university not in the United States. So we're not going to be able to use ACT, SAT as a placement, as a way to determine whether or not they're any good.
Is Case an Ivy League school?
No.
So are they just like smart in general?
Case Western is known for research. Like they're pretty good at what they do. All the Ivies are pretty well known for research, depending on the field. Some schools are just not known for research. They care more about educating their students than they do about research, and that's fine. It doesn't mean it's not a good school. It just means they're not a research institution, and that's not what they're interested in. In this case, these people are from the University of Wolverhampton. That sounds made up. Wolverhampton. Anybody? The name doesn't sound weird to anyone else. I read it this morning and I was like, but University of Wolverhampton or California Psychics, who do you trust? Who are you like, yeah, okay, I trust them? You're not making a choice between California Psychics.
No psychics.
Yeah, I thought that this morning when I heard the commercial for California Psychics. And you know why I didn't call, other than the fact I don't believe in psychics? The psychic they interviewed for the commercial said she was surprised at how difficult it was to be hired there and what a thorough background check they did. If you were surprised, how good are you as a psychic? Yeah, see? I was like, no, that's not a good thing. Nobody thought that through from the company. Like, nobody heard that commercial and were like, skeptics are going to think this? Because that was the first thing I thought. Who do you trust? We trust the people at Wolverhampton?
Yes.
Yeah, we'll give it to him this time. Still sounds made up. This is going to be really important for you guys. Says it was published in 2010. What do you think? We like 5 years or newer. 5 years or newer, so this is pushing it for age of article. But, you know, it falls within our 5-year margin. We'll take a look at it. The next step is to take a look at our abstract. Reading the abstract, I'm going to have you and your partner read the abstract. Your job is to identify independent variable, dependent variable, and method of measurement. Independent variable, dependent variable, and method of measurement. And ooh. That's about as big as I can make it without lopping off any words. So look for IV, DV, and how they measured. the first sentence with the single underline as their experiment. Like, this is what they did. And the double underlines are their independent variable. So, treatment with tea tree oil and silver at subminimal lethal concentrations, that was independent variable. And they go on further to tell us what they did was tea tree oil and silver, which they said here, and then they said individual agents. What that means to me when I read it, one experimental group got a combination of tea tree oil and silver. One experimental group got silver only. One experimental group got tea tree oil only. And there was a fourth experimental group. Your control group, the one who didn't get any antimicrobial. Now, that's true for each culture, which means that Candida had 4 treatments, that Staphylococcus had 4 treatments, and that Pseudomonas had 4 treatments. So how many total trials were there? 12. They told us all that right there. They just didn't have to use a lot of words to do it, right? Because we understand the scientific method. We know exactly what they had to do. The things I circled or boxed are the dependent variables. What they measured was loss of viability and sensitivity to combined agents. How do you measure those things? Like, what data do you collect from that? You have to have something measurable with numbers, right? That's what we're aiming for. Do you think there's a method for doing so? Did they tell us what it was in our abstract? It's just not obvious because it's not one we're familiar with. The fractional lethal concentration index. They made up a unit of measurement to say, if it is this lethal, if this many die or if this many are unable to survive, is a better way of saying lethality. If that few are unable to survive, then it was more effective. That's all they did. I am going to accuse you of something that some of you will outright admit, and some of you will just vehemently deny because that's not you. You're such a hard worker. If you are assigned a reading assignment, your method of doing so looks something like this. I will read the title. I will read the first paragraph. I will skim the rest of the page, and by skim the rest of the page, I will evaluate to see if there are pictures. And if there aren't, I click next until I encounter a picture. All those words on that first page, psh, words. Who uses words? That's dumb. And you're like, oh, okay, I'll look at a picture. Pictures are fine. I don't mind pictures. And that's how you read. Given a reading assignment for school, that's what you do. First paragraph, headings, pictures, and you're done. True or false?
True.
First hour was like, yeah, spot on. That's exactly what I do. And I was like, yeah, I had a sneaking suspicion. You know how you read these articles? You're going to do the exact same thing. All of these, I don't care about the words. They're emergency words. We use them in an emergency. If we see a graph, figure, or chart that we don't know what it means and we can't make sense of it, then we skim the emergency words for an answer. We don't read them, we skim them. That's it. So the first thing we do here is look at our graph, figure, or chart. At the top of the page, there is a table. How many of you are like, nah, this table looks too complicated? I'm done. Secretly, it's actually just a summary table. All they're telling me are the 3 things that they tried to kill, the amount of tea tree oil that they used by percent volumes, so milliliters worth, the amount of silver that they used in each trial by weight, and how that compared to the lethality, right? That index that they made up. That's it. Was that bad? That's all I needed you to gather from this chart. Guess what that means? Skip all those useless words and find another picture. Here's our next picture. Is it really a picture? What is it? It's a graph. What's on the x-axis? Time and hours. How many of you are like, yes, I understand time. Time's good. Good with time. And for which species are we looking at? The Candida, the yeast, okay. Here is probably something we're not familiar with. If you were a microbiologist, this would be a very familiar measurement to you. This is all we do. When we're trying to study the number of living cultures, we see how cloudy or how thickly concentrated the cultures are. The cloudier the substance we're looking at, the more cultures there are. All you have to do to figure that out is take a swab. You're going to centrifuge it, so you put it through a machine that spins really fast like the gravitron, and then you see how much light passes through it. That's all. This is just a fancy measurement for that. There's some machines that do it for you. So when you get to college, you'll do this probably in your first 2 years if you're a science major. It's not hard. You go in, you learn it in like 45 minutes, and you're done. So the cloudier it is, the higher the concentration of living things. The lower the concentration, the less cloudy. Tea tree oil plus silver, only silver, and control group. Those are the 4 groups we said they tested, right? Control group, do you believe is right here? What happens to the concentration of organisms in the control group? Stays about the same. No variation. Can we do a mathematical calculation that would tell us the change in concentration? Mm-hmm. That's all we'd have to do there, is calculate the slope of that line. You'd be done. How about for, what is this one? Silver only. Is that silver only?
Rises slightly.
Yeah, that's not very useful. How about, or was that, I can't tell if it's a circle or, well, that's clearly a square. How about tea tree oil and silver? So which of our samples was the best and fastest at killing? Tea tree oil and silver together. So when they said in that introduction, did you see the term synergistic effect? That just means that these two things work really well together. Guess what happens when you look at the next 2 graphs? Interpret them the exact same way. Axes are the same. It's just for the different organisms. Guess what? That's the graphs, figures, and charts. There's one more table that goes through the data that's on those graphs. It tells you the numbers, how they put the numbers on the graph, and that's it. That wasn't a whole ton of reading, was it? Took a little work, but not like cry-worthy work. You worked your way through it. You got to ignore all of those other silly words on the page. That's all you have to do with your articles that you found. That's the method. Title, authors, date, abstract, pictures. Don't pore over the words. Sometimes the words are interesting. Like earlier, when I did this with First Hour, I got distracted by this paragraph, so I had them do whatever so I could read. Sometimes they're interesting. If they're interesting, read it. If they're not, ignore them. One other thing to point out here. At the end of every article, they will show us competing interests and ethical approval. Ethical approval not required means that there was nothing about this that was going to injure someone, hurt someone, maim someone. This was not a Nazi experiment. This was not like a torturous experiment, so they didn't need any approval. This means nobody who produces like tea tree oil or anything like that paid us to do this study. If they'd been paid by a tea tree oil company, what would you be suspicious of? Yeah, you'd be like, yeah, that's kind of biased. So they just have to declare it at the end, whether or not there's anything there that would taint their results. So sometimes it's worth looking at, especially if you're doing an engineering project. Look at the end for anything in engineering, because sometimes the people who publish these are paid by very large corporations, and well, usually they want to find a particular result. So use whatever time you have remaining here